Okay, so in problem 2 from homework 2, you're asked to find the derivative of several functions using the limit definition. So just to recall, the limit definition says that the derivative is equal to the limit as h goes to 0, f of x plus h minus f of x divided by h. So this is what we're going to be using throughout this problem. So in A, we have the function f of x equals x cubed minus x. So let's apply this definition to that function. We have the f prime of x is equal to the limit as h goes to 0 of x plus h cubed minus x plus h. This is the f of x plus h term, minus f of x is x cubed minus x, and we have a minus sign here, so the minus there becomes a plus. And then we divide by h. You can then expand this cubic factor to get x cubed plus 3xh squared plus 3x squared h plus h cubed minus x minus x cubed plus x, all divided by h, and of course there's still a limit as h goes to 0. Now, if you look at this expression, there's some cancellations that we can do. There's a plus x cubed and minus x cubed, a plus x and a minus x. So if we simplify things as much as we can, we get 3x squared h plus 3xh squared minus h divided by h. I believe that's all the terms. And now we've succeeded in getting everything having an h in it, so we can cancel an h from each term and get that this is equal to 3x squared plus 3xh minus 1, limit as h goes to 0 of that. So this middle term as h goes to 0. The other two terms are unaffected. We just get 3x squared minus 1 as our derivative. And now that we've seen the power rule, we can quickly verify this is indeed the correct answer. So the second one, we're asked to consider f of x equals 1 divided by x minus 1. So let's again look at what the definition of derivative tells us. It says f prime of x is equal to the limit as h goes to 0, 1 over x plus h minus 1 minus 1 over x minus 1, all divided by h. Now we somehow have to simplify the numerator, so we try to find a common denominator. We multiply the first one by x minus 1 over x minus 1. When we do that, we get x minus 1 over x minus 1 times x plus h minus 1. Then we subtract. The second one we multiply by x plus h minus 1 over x plus h minus 1 to get x plus h minus 1 over that same denominator, all divided by h. And now that we've found a common denominator, we can combine these two fractions in the numerator. When you do that and apply some properties of fractions, you get negative h divided by h times x minus 1 times x plus h minus 1. You can now cancel these h's and get limit as h goes to 0, negative 1 over x minus 1 times x plus h minus 1. And if we take this limit as h goes to 0, we can now just plug in h equals 0 and get this is equal to negative 1 over x minus 1 squared. Okay, so then the last one has f of x equals square root 2x. So again, if we use the definition of derivative, we have the limit as h goes to 0, square root 2x plus h minus square root 2x divided by h. Now the trick here is we want to get rid of the square roots in the numerator, so we multiply this entire thing by the conjugate, so square root 2x plus h minus plus, square root 2x over the same thing. So in some sense we're rationalizing the numerator. And so when we multiply this out, the numerator simplifies a lot. It just becomes 2x plus 2h minus 2x, and the denominator becomes h times this entire thing. And we still have a limit as h goes to 0 that I've forgotten. Now we can cancel the 2x and the minus 2x. That just gives us a 2h in the numerator, and the h can cancel with the denominator. So this becomes limit as h goes to 0 of 2 over 2 square root x, square root of 2x plus h plus square root 2x. When you take this limit, this h going to 0 means that this just becomes square root 2x, so we get 2 square root 2x, and then the 2 cancels with the 2 in the numerator, so we just get 1 over square root 2x.